Hello guys, welcome back to Math Zone African Motives. Still on our revisions for mathematics grade 10, we shall be focusing on the June 2022 question paper that we are going to focus on, try by all means to work out. So this is paper 2 that you're going to expect to work within 1 hour. That is 50 marks for everything that you're given there. So we're not gonna waste much time. Just gonna quickly rush through the questions so that we can see how we're given our questions. So the first part is to read your instructions and the information that you are given, especially that here, you must be able to show everything. That is, the answers only will not necessarily be awarded full marks. So you are supposed to show all the working so that you can have the full marks, because you are given that answers only will not obtain the full marks. So you're supposed to simplify everything properly, and also, if necessary, round off answers to 2 decimal places unless stated otherwise. So these are the one that you're going to use unless we are told on that questions that you're on the question that you're going to answer. And also your diagrams, they are not necessarily drawn to scale. That means everything that you're going to have is just a diagram. Do not think that it's up to scale. When you see a diagram like this, it's not up to scale. It's just a diagram that is being drawn that you're going to work with, not to say you have to measure it. No. All right, so that was question number 1. Study the diagram below and answer the questions that follow without the use of a calculator in this case. All right, so let us see what we have. So we're given in this part, that is the application of our Cartesian plane with the x-axis and the y-axis, and also the angle theta that is corresponding to our terminal point at P, which is given as -4, -3. So take note there, we've got the x value and the y value corresponding. So the question was to determine the value of 1.1, which is sine theta. So as you can see, to find this sine, we have to complete our diagram, form a right angle triangle so that we can use our ratios. Remember, from the application of our ratios for our SOHCAHTOA concept. All right, so that's SOHCAHTOA. We are going to see that we need actually to complete the diagram so that we can use as a right angle triangle. So here we can just join up to this point, to the horizontal line. That means this will be at 90 degrees. So there, at the point P that you're given, what we have, like I indicated, is the x value, and also we have the y value that is corresponding at this point. So what you're going to do is that we have to replace these values according to the triangle that we are given here. So these are the x values, as you can see, our x-axis. So to this side, your x will be negative. So that's where we have our x value here, which is what? A -4. So it means from this point up to this point, it's -4. And the y value being -3, from this point up to this point, it's a -3 in terms of the direction that we are going down to the y-axis. So these values, they are negative. If it was on top, it was going to be a positive. So what you're going to need is to find your r in this case, which is the hypotenuse of the given triangle, the one that always faces the 90 degrees, so that we can be able to determine the ratio of sine. Remember, the ratio of sine is the opposite over the hypotenuse. So definitely you're going to need your hypotenuse in that case. All right, so where are you going to have the hypotenuse? Remember, hypotenuse squared, which is r squared, is equal to x squared plus y squared in that case. So that means we can obtain the value of r, which is the hypotenuse in that case. So that means r squared is equal to x squared, which is the value of x, that is -4 squared, plus y squared, the value of y down there, it's -3. So that's -3 squared. So we can simplify this. -4 squared simply means -4 times negative. And remember that a negative to the exponent of 2, that is an even number, it becomes a positive. So 4 times 4, which is 16, -3 squared, which is a 9. So we can add these to 16 plus 9, which is going to give you a 25. So to determine r, is just going to introduce the square root so that you get rid of that square that you're given there. So the square root of 25, which is plus or -5. So remember that this is the resultant and which is representing the hypotenuse, and this cannot be a negative. Always this one is taken as a positive. So we're going to have this as a positive value. X can be negative or can be positive on this side. Y can be positive, can be negative. But the hypotenuse, which is the value of R in this case, this one cannot be negative, whether it's down or it's on top like this. This R, which is the hypotenuse, is always a positive. So now we have completed our diagram. We are going to answer the first question that we are given in this case, which was to determine the value of sine theta. So from this ratio that I indicated here, it states that the sine of theta is equal to the opposite over the hypotenuse. So we're going to use the opposite over the hypotenuse in that case. That means the sine of theta from our diagram, we are going to take, this is our theta. Yes, this is the theta that they are referring to. But as you take your ratios, you're going to use the angle that is inside the triangle. Make sure that you watch the video on the introduction. I talked about this, that you use the angle that is inside of the triangle. That is the one that you take its ratio, but that ratio is equal to the ratio of sine theta that you see there. All right, so that is sine theta. Remember, it's opposite of hypotenuse according to this theta. According to this angle that is inside of the triangle, the sides that we have in this case, we are going to have this side, which is the opposite. It is facing our theta like this. They are facing each other. So that is your opposite. Remember, we talked about the hypotenuse. This one is not going to change. The one that always faces 90 degrees. Then theta and 90 degrees, I mean, this angle and 90 degrees, they are sitting on this line together. So that is your adjacent. So they are on the same line. So they are adjacent to each other, these two. So you've got the adjacent there. So what you're going to simply do is to substitute to the formula that you're given the opposite, as we can see here, that is -3. So you're going to have -3 over the hypotenuse, which is our hypotenuse there. It's a positive 5. So that means our answer was going to be -3 over 5 in that case. All right, so let us check the other part of our question. So with the value of R that you have, or whatever that you have from this diagram, you can be able to answer any question for any ratio that you're given. Like if you check 1.2, we are given to find now this time the value of that is 5 cos 90 minus theta. All right, so what 90 minus theta, this one, what does it represent? The cosine of 90 degrees minus theta is equal to the sine of theta. And also you must know that if it is for the sine of theta, the sine of 90 degrees minus theta is equal to the cosine of theta. So it changes, cos changes to sine, sine changes to cos, all right? Whenever you see this 90 minus theta, 90 minus theta, all right? So cos 90 minus theta, it's sine theta. Sine 90 minus theta is cos theta. So meaning to say, we can now change the whole of this cos 90 minus theta, the whole of this cos that we see, we are going to change it into a sine. So it's going to be 5 sine theta in that case, all right? Like I said, cos 90 minus theta is equal to sine theta. Then if it is sine 90 minus theta, you use cos theta, all right? So this is going to be plus 3 cot theta, all right? So remember, cot, we do not have a condition that we are going to use for cot, like direct on our calculator or even here. So what are we going to do? We are going to change the cot into a ratio that we can be able to use in our simplification, all right? So remember that cot simply represents 1 over tan theta, all right? This cot here simply is a reciprocal of tan theta. So it's 1 over tan theta. That is the reciprocal. Remember tan theta here, it's opposite over adjacent. The value of tan theta is opposite over adjacent. And cot theta is 1 over tan, which is the reciprocal. So the reciprocal means you are going to interchange this. So that means the cot of theta is going to be given as the adjacent. This time you interchange, so it's going to be adjacent over the opposite. So that will gonna be adjacent over the opposite in that case. All right, so you can use that direct if you want, because you have direct, or you can use 1 over tan. You find tan theta from here, then you use it as 1 over tan theta, or you can just write this direct as adjacent over the hypotenuse, that is 1 over the tan of theta. All right, so let us substitute our values here. We are going to have 5 sine of theta. Remember, we said cos 90 minus theta is equal to sine 90. So we're going to use the value of sine theta, and sine theta, we obtained it before. We got -3 over 5. So that is going to be -3 over 5 in that case, plus 3 times 1 over tan, which is cot in this case, which is adjacent over the hypotenuse. Remember, it's the vice versa of tan theta. 1 over tan means the reciprocal. So we're going to use adjacent over the opposite in that case, all right? So according to this, the adjacent is -4. So we're going to have -4 over the opposite, which is -3 in that case, okay? So if we simplify this properly, you can see this is same as over 1. So this was going to cancel at the end. You obtain 1. 1 times -3, which is -3. Then here negative and negative was going to cancel. 3 and 3 cancels. You remain with a 4, which is a positive in that case. So meaning to say -3 plus 4, that is going to give you a 1. So this simply means 4 minus 3. So it simply means we've got a 4 minus 3, which is a 1. So as long your triangle has got everything, it's going to be easier for you to find whatever ratio that you're given. All you just need is to manipulate your ratios in a proper way so that you can properly answer your question. So that was the first question. Then question 2, which is actually having 7 marks there, we are given to determine the acute angle. So like I said, in our syllabus, we're going to be considering the acute angle. So there's nothing much that you're going to talk about, the issue of the reference angle, this and that. All you just need is to find the angle, and the angle is simply the arc of the ratio that you're given. If it is sine, it is arc sine. If it is cos, arc cos, depending with the ratio that you're given. So on 2.1, we are given that is the sine of beta minus. So that is 2.1. We're given the sine of beta minus 17.8 degrees. And this is equal to 0.215. So what you simply need in this case is to find the angle. And the angle is this part here. As you can see, we do not have any other number that is affecting sine, whether it's a multiplication or it's a division. It's just the angle, this one. So in order for you to remain with the angle, which is beta minus 17.8, it is going to be arc sine on the other side. So on this side, you're going to write it as arc sine of 0.215, all right? So that is going to be arc sine of the value that you're given here on the other side. So that means you now have the angle equal to this angle. So you can work out the value of beta since these two are angles. So 17.8 is equal to, so that's beta, minus 17.8 is equal to the angle that you're going to get from this part. And remember, two decimal places in that case. All right, so we're going to need our calculator. And also on your calculator, what you're going to do, since you need your answer to 2 decimal places, change your calculator to 2 decimal places in your simplification. That is going to be shift. You go to the mode, in this case, which is the setup. So on this setup, you're going to number 6, which is to fix your calculator to 2 decimal places. You press 2 like this. So automatically, your answer is going to round off the answers to 2 decimal places. All right, so let us find the value of arc sine, which is shift sine like this, 0.215 like this. So we're going to obtain the angle that corresponds to this value of what? Arc sine, which is the angle now, which is 12.42 degrees. So this is going to be 12.42 degrees. That is the angle that we saw corresponding at 12.42 degrees. So to find the value of beta, since these are angles that we are talking about, we can work all with them. We can even transpose this to the other side so that it can be a positive. You remain with the beta in this case, all right? So that is what you're going to simply do. We are going to transpose negative 17.8 to the other side. So if we transpose this value, it is a negative on this side, it is going to add. So we're going to add 17.8 on that side. You obtain the value of beta. So here, just simply add 17,8. All right, so that's 17,8 like this, which is going to give us 30,22 degrees. So that is 30,22 degrees. All right, so that is the value of beta that we are going to have at the end. All right, let us check question 2.2 again to find the value of beta, but this time we are given a condition that tan of 3 beta is equal to the square root of 3 in that case. So as you can see, this was a direct question. We do not have a lot of things to consider. Just determine the angle, and this is your angle, which is 3 beta in that case, all right? So 3 beta is going to be equal to, we've got the square root of 3 in that side. So in order for you to have the angle, you're going to remove this tan this side. So to remove tan, you write it on the other side as arctan, just like what we did on sine, it was arcsine. So this one is going to be arctan, the square root of 3. So that's, we've got the angle, which is 3 beta equal to the angle that we are going to get here. So that is 3 beta is equal to arctan, the square root of 3. We are going to need a calculator in that case. So let us just go to the normal setup and we find our arctan in that case. All right, so that is arctan, the square root of 3. So this one, it gives us a direct answer, which is 60 degrees. So there we are not having, we are not rounding off anything. But if the number that you obtained there has got decimals, then you can go back to the fix, you round off to 2 decimal place. But this one, it's a whole number, just going to write as it is, which is 60 degrees. Remember, like I said, this is an angle. So here you are now having an angle which is 60 degrees. So to find beta, we can divide by 3 both sides. That means we are going to obtain the value of beta, which is 20 degrees in that case. Or you can just divide on your calculator, divide by 3. You are going to obtain 20 at the end. All right, so this is how we could have simplified this question, which is the same idea or the same part that you're going to apply on question 2.3, where we are now given, in this case, this is 3 sine of beta over 2. So there we've got beta over 2, which is equal to 2,012. All right, and there we need to find the value of beta. So take note, the angle is this part that we have. This is the part of the angle of beta over 2. And if you are to check, this part is not an angle that we have, which is 3. It's just a number that is multiplying the ratio of sine that we are having. So we can remove this 3 by dividing, since it is multiplying. So we can divide by 3 both sides. That means we are going to obtain, in this case, the sine of beta over 2, which is equal to 2,012. That is 2,1012 like that over 3. All right, so that is what you're going to have. This is 2,012. All right, so on this part that we are having, yes, you can simplify this as a decimal, which if you want, but what is important is that, guys, we just want to remove this sign here so that we remain with the b over 2, beta over 2, which is our angle. So the beta over 2 is going to be simply to remove this sign, like I said, to be written on this side. You're going to write it as what? As arcsine. So this is going to be arcsine 2,012 over 3. That is how you simply play around with this. That means the moment you want to remove this, whether it's a cos or it's a tan, on the other side, it is going to be having now arc, which is this negative one that we are having there. All right, so now that this is an angle, we can use our calculator to simplify the angle. Then we can equate to beta over 2, because we've got beta over 2. So beta over 2 is going to be the angle that you're obtaining here. And that part, you can simplify direct to 2 decimal places, since we are given the instruction. So let's see arcsine. This is arcsine. We are going to have the fraction in that case. So that, just put a fraction there. 2,012 over 3 like this. All right, so we're going to close our bracket, which means we are going to have 42,118 and so forth. Right, so to round off to 2 decimal places as per instruction, just shift set up, you go to the fix, then 2 decimal place, you press 2. So it is going to give you the answer to 2 decimal place, which is in this case, we are going to have 42,12. All right, so this is 42,12 degrees. Remember, this is now an angle, so we are going to have this 2 degrees. All right, so with this angle that you are given, in order for you to obtain beta, because this is same as over 1. So to obtain the angle beta, you can simply cross multiply. This multiplies here, this multiplies here. So that means 1 times beta, we are going to obtain beta in this case. Then 2 is going to multiply the angle that you're having. So this angle times 2, you're going to obtain 84,24. So that is 84,24 degrees. So that is the angle beta that we are supposed to actually have on this question. So you just have to be careful in your simplification, how the questions are given. Then you'll be able to attempt any question that you be given of this nature. All right, so that was our question number 2. Let us check question number 3, which is 4 marks on this part. We're given to determine this 4 marks for that. All right, without the use of a calculator. So there we are told not to use a calculator, all right, without the use of a calculator, right? So the theta, it's an angle from 0 to 90 degrees. All right, so on a condition like this, all you just need here is to work with your special angles. Remember, from those we've got tan 30, cosec, cos, and this. So there we just need our special angles there. All right, so in actual sense, remember from your special angles that you've got the first part, when you are working the angle of 45 degrees, this is 45, this is 45, this is 1, 1, we've got the square root of 2, and we've got a condition whereby you're working with the angle of 60 degrees, whereby this is taken at 60 degrees, this is 30, this is 30, we've got the square root of 3, this is 1, 1. All right, and this is 2, this is 2. So this triangle that we see on this side is the same as this, so we can even erase this and just work with one triangle like this. It's just one and the same thing, okay? Just one and the same, because what we had on that side was the same as what we have on this side. So you can just use it like that, right? So anyways, let us see what we have this question, which is question 3. So we are given tan 30 degrees, all right? So remember, from our ratios, we got a SOHCAHTOA. So let us just give it here, SOHCAHTOA, sorry for that. So this is SOHCAHTOA. So from that part, we know that the tan is opposite over the adjacent. So that means we are going to need, according to 30 degrees, according to the angle of 30, this is the opposite, the one that is facing 30 degrees. So that is our opposite, which is 1/2. Times, in this case, we are going to need the cos, all right? So that is 1 over opposite over the adjacent, which is 1 over the square root of 3. So there we're having the square root of 3. Opposite, it's 1, and our adjacent in this case here, which is the square root of 3. So there we've got 1 over the square root of 3. So this is 1 over the square root of 3, which you can write as the square root of 3 over 3 if you rationalize the denominator, or you can just leave it like that. You do not know what's going to happen on cosec, all right? So remember that cosec is taken from the reciprocal of sine, all right? This is cosec 60 degrees, which is simply taken from the reciprocal of sine. So we know that this is 1 over sine 60 degrees. All right, so if it is the reciprocal of sine, and we know that sine is opposite over the hypotenuse, and the reciprocal is then vice versa now. So it's going to be hypotenuse over the opposite. That is the reciprocal, because we have got the sine. It was supposed to be sine 60 is equal to opposite over hypotenuse. But now for cosec, since we are saying is the reciprocal of sine, so it means it is going to be hypotenuse over opposite in that case, all right? So this is going to be the hypotenuse over the opposite. So we're just going to take our values direct as it is, meaning to say, according to 60 degrees, this is our 60 degrees. So we're going to take the hypotenuse, which is 2, all right? So our hypotenuse there is 2, does not change. So we are going to multiply to 2 over the opposite, all right? According to 60 degrees, the opposite there is the square root of 3. So that is our opposite. So it's going to be 2 over the square root of 3. All right, everything over the cos of 45. Remember, cos adjacent over hypotenuse. So depending with which angle of 45 are using, if you are using this angle, this is your adjacent, and this is your hypotenuse. So it's going to be 1 over the square root of 2. So we've got 1 over the square root of 2, all right, which is going to be multiplied to sine 45, which is opposite over hypotenuse. So opposite, which is 1 over the hypotenuse, which is the square root of 2. So as you can see, this is a single part that you are having. This is a single part that we are having at the end. So you can simplify and see what you're going to have at the end. And as you can see here, it's now an application of our sets. Since we are not, we are told not to use a calculator, and there we just need to apply our laws of sets, and which states that, remember, the square root of a number, when multiplied to the same number, the square root of a times square root of a is equal to a. If the numbers are the same under the square root, then we are going to have that number that is under the square root. So it means the square root of 2 times the square root of 2 is equal to that 2, the number that is under the square root as it is, which is the 2. So that is the condition that we have here. And as you can see, we can multiply the numerator to the numerator on the first part. So that is 1 times 2, which is 2 over the square root of 3 to the square root of 3. We are back now to the square root of a times square root of a, which gives us a in that case. So meaning to say, if you multiply square root of 3 and square root of 3, you're going to take the number that is under the square root, which is what? Which is 3. So that's 2 over 3 divided to 1 times 1 on the denominator. We've got 1 over the square root of 2 times square root of 2, which is the same thing that we talked about here. So this is going to give us a 2. So that means, remember, if you are dividing, you're going to introduce a multiplication, then you flip the second fraction. This is a division that you're simply having there. So we simply have 2 over 3 multiplied. We flip this fraction interchange. So it's going to be 2 on top and 1 down. So that is going to be 2 over 1. So you can multiply 2 times 2, which is 4 over 3 times 1, which is 3. So that's what you're going to have. But like I said, the use of the part of not using a calculator here is important on this part. The other part, you can just use it. No one is going to know that you have used a calculator to multiply square root of 3 times square root of 3. So you can just use a calculator, but the major part is, are you showing the necessary steps that are being required or that are needed? Right here, you combine this to be a single fraction, which is this one, the same as this part, which is a single fraction. Then you go back to the state that this fraction on top, which is 2 over 3, is dividing this fraction below, which is 1 over 2. So if it is dividing, what does it mean? It means I'm going to introduce multiplication, then I invert the second fraction, I flip the second fraction, so it's going to be 2 over 1. Then I can multiply the numerator to the numerator, the denominator to the denominator, which is going to give us a 3. So that is 4 over 3 for that. So that was our question number 3 in that case. All right, so let us check the other part of the question and see how we're given the other part of our questions, which is very, very important for you to be able to understand these typical questions. That's question number 4. The diagram below represents the graphs of f of x, which is a sine x, and gx, which is b cos x, for the interval 0 to 360. So we put our interval taken from 0 to 360 degrees. All right, so this is our f of x, which is a sine x. All right, so this is our a sine x, this one. Then gx, which is the one of b cos of x. All right, so the question is on a, write down the value of a and the value of b. So they were just asked you to write down, which means they know that you can just actually be able to manipulate or take this value. So how do you know the value of a or the value of b? So we have a formula for that you can use, or you can simply check here where your graph touches, or where your graph reaches the maximum value. This a here, it represents where your point is reaching the maximum value, but depending with the input at the point where you're supposed to have the maximum. At this point, our maximum was supposed to be this side, like this, but we are having our graph in the other way. So we are working with the first point of our minimum value. At the minimum value, what we have, the minimum value there is -2. So A is going to be equal to -2 in that case. All right. So this A is equal to -2. Then B, for course, it is happening or it is moving in the normal way the graph of course is supposed to be. So the maximum value is the one that you're going to take, which is the maximum value there corresponding at what? At 1, not the minimum value. But if it was a condition like our graph is like this, all right, maybe our graph like this, it means our B was going to be -1, where it is having a maximum. It was supposed to be at 1, but now it's happening at -1, just like what happened here. It was supposed to be on top there at 2 like this. This was supposed to be the graph, but now this value was multiplied by a negative. Now it is down here. So that's why we are taking that as a -2. But for this one, for B, it is going to be a +1, which is the maximum value there. So just a +1. All right. So that's why they are saying write down. It's not like determine or calculate. It's something that you can just have or see. But there's a formula that you can also use for that. All right. Which is in this case to find the value of A. We're supposed to use the formula half of the maximum value, which is the one for the amplitude, half of maximum value minus the minimum value. This is the formula that we're supposed to use. But as you can see, the graph is in the opposite way, the one that it was supposed to use. So we're going to use this as a negative, or you can interchange minimum minus maximum, all right? Or you use that as a negative here. So it is going to be -half of the maximum value. Our maximum value does not change its position. It's found at 2 minus the minimum value, which is at what? Which is at -2 like this. So this is going to give us a 4, negative. That's a positive there, which is going to give us a 4. So that's a -half times 4, which is going to give us -2. So that is how we could have calculated the value of A, which is the same as the value of B. The value of B just going to take from the maximum. This one, we are not interchanging anything because our graph is in the normal way. So it is just going to be half of the maximum value, which is at 1, minus the minimum value for GX. The minimum value is at what? At -1. So it's going to be -1 like this. So that is half of, you're going to have a positive 1 plus 1, which is 2, and half of 2, which is what? Which is 1. So as you can see, we're having the same answer, just like what we could have done on this part, right? Let me just leave it because there's a question here that needs the amplitude. All right, if you check this question of 4.3, I'm going back to 4.2, but I want us to see 4.3. They're saying, what is the amplitude of F? We using this method that you're talking about. This is not the amplitude, this one. Here we want the maximum, like the value of A and B. If you are using amplitude, there is no negative that you use. The amplitude is direct half of maximum minus minimum. All right, that is the condition of the amplitude. So if it was a condition of the amplitude, you're just going to use this as a half, as it is. So that is a condition when it is for the amplitude. You're going to use this formula as a half as it is, half of this value as it is. So meaning to say, we are going to have half of 4, which is going to be a 2. So here you are going to obtain your value as a 2 in that case. All right, so I just hope we are together on this part. All right, let us check this question. 4.2, they are saying, what are the conditions that for which values of x will g be decreasing, will be a decreasing function? So when they're saying it's a decreasing function, this is how our graphs are given. Like, so decreasing is like a condition where you're getting from maximum value going down, that is to decrease, up to the minimum value. From a minimum value going to the maximum value like this, you are increasing. So this one is a decrease. This one is an increase. All right. From a maximum value to a minimum value, as you are going down, you are decreasing. That's a decrease. All right. Minimum value going to the maximum, it's an increase. That's what you simply need there. So they are saying for which values or for which values of x are we going to have our function of g decreasing? So let us check where our g is decreasing. That is what we just need from the graph. We're going to need the graph in this case, all right? So from your functions that you have in this case, this is your g. As you can see from 1, this is our g from 1. As it is going from 1, is decreasing, it's decreasing, it's decreasing, up to a point where it is going to reach a minimum point at this point at 180 there. This function it was decreasing all along. It was reducing. It was 1. Now maybe it's 0.8, 0.7, 0, it's reducing up to 90, which is 0, negative 0.1, negative, up to negative 1. The moment it reaches this point at 90 versus negative 1, it is now going up. It's now increasing. This side is now an increase up to the point at 360. Because at 360, it is going to reach a maximum value. The moment it reaches 360, it is now starting to decrease. The function is now starting, but this one is now out of the interval because our interval is taken from 0 to 360. So from 0 to 360, from 0 degrees to 360, we saw that our function is going to decrease from 0 degrees. That is the x value there, it's 0. Yes, the value here is 1, but it corresponds with the x at 0 degrees, up to a point where x is 181, the value of x, where our function is decreasing. So it started at 0, it was at 0, it's actually at the maximum at 0. So it starts to decrease the moment at a value that is now greater than 0. So on your answer here, when it is decreasing, you are going to write this as x is greater than 0. Because at x is equal to 0 here, at x is equal to 0, it's not increasing, it's not decreasing. It's at a stationary point. The function is not moving. But the moment it starts to, the moment you start to say 0.1, 0, the function is now decreasing up to 180, just before 180. At 180, it is no longer moving at 180, it is just stationary. The moment you move from 180, it's now 181, 182, it's now increasing. But at direct 180, your function is called stationary, it's not moving. So meaning to say the proper answer for our x was supposed to be x is greater than 0 degrees, but less than 180. Not to say it's equal, because when we say it's equal to 180, at this point 180, it's not moving. It's stationary at that point. There's no movement that is happening. All right. So we can't say it's decreasing. We can't say it's increasing at this point. But the moment we start, we just move a slight point. It's now increasing. So be careful on how you are going to have your final answer at the end there. All right. Then 4.4, what is the range of G? So the range, these are the Y values that we are going to be talking about. What are the Y values that are affecting G? So our G is limited from the minimum value. This is the Y value at the minimum value, which is at -1, to the maximum value, which corresponds at +1. It cannot exceed these 2 points, -1 or +1. So meaning to say Y can be written as greater than or equal to -1, but less than or equal to 1, or you can just write this as Y is an element of values from -1 up to +1, like that, right? So that is what you're going to have. Then 4.5, for which values of x is f of x minus gx equal to 2? We talked about this type of a question in another question. If you still remember, there's another part that we talked about it, and I said this one, it's a distance, the difference between two functions. It's a difference that you have between two functions. So they are saying at which difference of the two functions, at which point of x we need the values of x. X is supposed to be the answer. But where do we have f of x minus gx giving us a difference of the x, a difference of 2? So take note, it's f of x minus gx. So meaning to say f of x must subtract gx in order to get a 2. F of x must subtract gx. Let us check from our diagram. All right. If you check from your diagram, let us do this so that we can properly see our diagram here. If we do this, this is our f of x, which is this one. That is our f of x. Remember, this is our f of x. So our f of x must subtract gx. So we need a condition where f of x is subtracting gx to get a difference of 2. So if you are to check here, f of x is down in the negative. There is no way it can subtract gx on top and it gives us a negative value there. And it gives us a positive value of 2. There's no way, because we are saying negative, it's in the negative already. And these values that we see, they are below below 1. If you check there below 1, if you check negative, here, let us just take an example. 0 versus 1. Let me just move you stage by stage because it can make sense. When I move you stage by stage, let's move just stage by stage. At 0 degrees, this is the value of x. What is the value of f? Because we need f of x minus gx. What is the value of f on this function at what? At 0 degrees. The value of f there, it's 0 because you are at the same point here. That is where it is starting. So the value there is 0 minus. What is the value of g at 0 degrees? The value of g, this is our g. G is at what? It's at 1. So if we subtract 0 minus 1, what do we get? We get minus 1, not a 2. All right, let's move on to 90 degrees. At 90 degrees, what is the value of f? F is the one that you need. So f at 90 degrees there is what? It's negative 2. That is at 90 degrees. Our f, which is the function of f of x, this one, it's at what? Minus 2. So that's minus 2 minus the value of what? Of g, because it's f of x minus gx. At 90 degrees, it's what? It's 0. So this is going to give us 90 degrees. So this is at what? At 0 degrees. At 90 degrees, we move on to 180. At 180 degrees, we want to see what's going to happen. At 180 degrees, as you can see, our f is the one on top, and we need f of x. So f of x at 180 degrees, this is our f of x here. At 180, it is going to be at what? At 0. It is going to correspond at 0. It's on the x-axis, and in the x-axis, the value of y is equal to 0. So that means there we have got a 0 minus gx at 180 degrees here, gx, which is this one. Remember, this is your gx. At 180 degrees, the value there, it corresponds with what? With minus 1. So it is going to be 0 minus 1, which gives us a 1. That's 0 plus 1, which is not a 2. So we do not have. All right, let's move on to 270. We are now at 270 degrees. At 270 degrees, what is going to happen at 270? All right, at 270 degrees, we are going to see that the value of f of x, because we need f of x, this is at 270 here. The value of f of x there, it corresponds with what? With 2. So that's 2 minus the value of gx at 270, the value of gx is on the x-axis, and I said in the x-axis, y is equal to 0. So it's 2 minus 0, which is what? Which is 2. All right, let's move on to 360 and finish up. At 360 degrees, our f of x is now at 0. It's on x-axis, so it's going to be 0 minus the value of g, which is on top there. G is going to be corresponding at 1. 0 minus 1 is what? Minus 1. So you're going to see that on all these special points, which is 0, 90, 180, 270, up to 360, the only part that we have a difference of 2 from the graph of f of x to the graph of gx, and we have a difference of 2, is at 270 degrees. That is the only part that you can subtract the value that we have on f to the value of g, and you get a difference of what? A difference of 2. So that is our x value at 270 degrees. The question here needs the values of x. So meaning to say x is going to be at what? At 270 degrees. So if you understand your graph, there is no need for you to be doing this point by point. Here I'm just proving so that all of us, we understand what is happening on this type of a question. But if you are to check by just me looking into the question, if you just check your question, there's no difference of 2 here. There's no, you can even see that by just looking onto your graph, this is now a condition that shows that you are actually revising, if you can be able to do that. But if not, does not mean that you cannot answer this question. You can answer this question using this way that I was using here. You go to the 1 point, 1 by 1, 1 by 1. You use as it is f of x minus this. If it was gx minus f of x is equal to 2, you have to start with the g. So it's going to be gx minus f of x. So the value of g, which is now 1 minus 0, here it's 0 minus 2. So you have to work with the gx on top, all right? So if you are to check, if it was for this one, if they said gx minus f of x is equal to 2, as you can see, our answer was going to be here, whereby gx here, it's at what? It's at 0 minus f of x, which is at what? At -2. So 0 minus -2, it gives us what? It gives us +2. So that was going to be at what? At 90 degrees. I'm saying if they said gx minus f of x, your answer was going to be at 90 degrees. I don't know if there's any other answer, but that is, I think, the only answer that you're going to have. All right, so you just have to revise, guys, as much questions so that you properly understand and also go through the introduction. I think on trigonometry, I've got every introduction of each section. Is it sketching of graphs? Is it answering these types of questions? Every question, is it on your geometry? Every topic we have the introduction. So go back to the introduction, watch the videos on the introduction so that you understand. Question number 5, use the list of quadrilaterals given below to answer the questions that follow. So these are the quadrilaterals. We've got a parallelogram, rectangle, rhombus, a kite, a square, a kite, and a trapezium. Write down the name of the quadrilateral or quadrilaterals that have the following properties. So they can be one answer, they can be two answers. All right. The first one, diagonals bisect the interior angle. So there you just need to know the properties of your shapes. I think with the video that we explained about the properties of each shape. So remember, on our properties, we said the one that the diagonals are going to intersect the interior angles. The interior angles are the angle that are inside of the shape is on a square or on a rhombus. These diagonals here, they bisect the angles inside. They divide the angles inside into two equal angles, 45, 45. So this condition is on a square. But remember, what a square gives mostly, a rhombus is also found there. All right, so we also have a rhombus on that part. Then the diagonals have same length. All right, a square also diagonals, they've got same length, but for a rhombus they are not of same length. Remember, a rhombus, yes, the sides, they are of equal length like this, but these will be your diagonals this time like this. So as you can see, they won't be of equal length, but for a square, our diagonals, they are of equal length, and also on a rectangle, they are of equal length. Also, the diagonals are equal on a rectangle. Then the diagonals, they bisect the area of the quadrilaterals. That is, they divide the area of the quadrilateral like this one, to say this diagonal here, they divide the area into two, meaning to say the area of this side is equal to the area of this side. This is what the question is all about. So it happens truly on a square. This area and this area is going to be the same. So it can happen on a square. It can actually happen on a rhombus. Yes, on a rhombus. Again, this one is there. As you can see, this side here and this side is going to be the same. So also on a rhombus, you are going to have the same thing. Also on a parallelogram, it's gonna happen, and also on a rectangle. All right, on a parallelogram, and also on a rectangle. All right, so you're going to just write any of these answers there. All right, so that was it on question 5. Then 5.6, question 6, actually not 5.6, but question 6, PQRS is a parallelogram. So here we are given that this is a parallelogram that we see here. All right, let us check our properties. Truly, it is a parallelogram. All right, so it means these two sides, remember, they'll be parallel and equal. So PQ, this side of PQ, and SR, these sides will be parallel and equal. So it means PQ is equal to SR, right? We're not given this information. All right, here we're not given, but we are given another information that we also have, that these two, they are now equal, but in the normal sense, these two sides are equal. All right, these two are equal. Let me just indicate something so that we can see. These two sides, they are equal. All right, the same thing on PS, it is parallel to QR like that, and they are also equal. So these, they are also equal. All right, so that you can know that they are also equal. Okay, so the question was, you are given also another information that this is their own information, not on the properties of a parallelogram. No, the properties of a parallelogram are the ones that I indicated, that these two sides are parallel and equal, opposite sides are parallel, and not this one. This one is their own. This is another part that they want to create for us. All right, let's see what are they saying. They are saying PQ, PM is equal to PQ. PM and PQ, they're equal. So it means there we have got an isosceles triangle that you're going to have. Remember, from the opposite angles that are opposite sides that are equal, we are going to obtain equal angles. So it means M1 and Q1, they'll be equal, right? So this angle M1 is going to be equal to Q1, which is the base angles of an isosceles triangle, or the angles that are opposite what equal sides. So that's another thing. Angle Q1 is going to be equal to angle M1, all right? Then another thing that you're given is also that SR is equal to MR. These two sides are equal. So it also goes to say the angles opposite these sides, they are going to be equal. So it means angle S and angle M3, they are going to be equal, all right? Angle M3 is going to be equal to angle S. This is what you're given from our triangles, not to say it's part of a parallelogram. These are not properties of a parallelogram. No, this is just another information. The properties are the ones that we have at the outer part. The information that follows is just something that is being created. So now they want to test you with this information. All right, determine with reasons two other angles which are equal to x. All right, so we need angles that are equal to x. And as you can see, we've got our x here. This is our angle x, which is at angle Q2. All right. So we need other angles equal to x. You can see that from the concept of these two lines being parallel, we are going to obtain a z there. That is alternate angles. We are creating a z. Remember, the angles that we have inside will be equal. That is angle M1 is going to be equal to Q2. That is alternate angles. So M1, all right? So also M1 will be equal to x, all right? So this M1 will be equal to x from the alternate angles, all right? So these are alternate angles. Let us just write in short, alternate angles. Then the other part, so this is x, but remember what I mentioned here about M1 and Q1. We said Q1 is equal to M1 from the concept of what? The angles that are opposite equal size. So that is here is going to be x. So that means also Q1 is equal to x, all right? From this part that we stated before, these are angles opposite equal sides, all right? Angles equal opposite sides, right? So angles opposite equal sides, so that will be x and x. So we've got another x, another x. So is there any other x? Let's see. All right, so that is the only part that we have. We do not have a part that we can even create a z. All right, so yeah, for the meantime, that is what we only have, where we have got x, 4 marks for that. All right, so 6.2, determine the size of M3 in terms of x. They are not saying M3 is x. No, they are saying in terms of x. Our answer is supposed to have x. So we need to determine angle M3 with x inside. All right, so this is our angle M3 here. And like I said, angle M3 is equal to angle S. All right, angle M3 is equal to angle S, which is fine. But if angle M3 is equal to angle S, then that means we can find angle M3 direct. All right, so we have the answer there. All right, the answer is already there, guys. I want you to see something here. Let me just work it aside. Maybe we can properly see. This is 6.2. All right, this is 6.2. We have got an answer which is direct there. So, because we said angle M3 is equal to angle S, remember? But from the properties of a parallelogram, remember we are told that this is a parallelogram. We know that opposite angles of a parallelogram, they are equal. The whole of this angle Q, the whole of this angle Q is equal to the whole of the angle S, which is the same concept here. The angle R, the whole of it is equal to angle P. These are the properties of what? Of a parallelogram now. So you're saying angle S, so we know that angle S is equal to angle Q. So you're talking about the whole of angle Q, which is a combination of Q1 plus Q2, all right? So these are opposite angles of a parallelogram, all right? So these are opposite angles of a parallelogram, all right? That is of a parallelogram, right? So if they are equal, and what is our angle Q? The angle Q is a combination of these two angles, x and x. So it's going to be x plus x, which is 2x. So that means angle S is equal to angle Q, which is 2x. And here we said M3 is equal to S. Remember, what we need here is to find angle M3, all right, in terms of X. And we said M3 is equal to S. But remember, M3 is equal to angle S, which will be equal to 2x, because angle S is equal to what? 2x. So therefore, angle M3 is going to be taken as 2x. All right, so that was our angle M3. But this is not like the only part. This is not the only answer that we could have it here, because if you check here, someone could have just used this concept here, because if you check properly, we said M1 it's x, all right? Then M2 it's 90 degrees, as you can see, we're given a right angle triangle there, so it's 90 degrees. Then M3 can be obtained because we're talking about angles on a straight line which add up to 180 degrees. So it means that we could have calculated the same angle M3 as this. So we could have calculated this as, remember, if we add angle M1 plus angle M2 plus angle M3, all these three angles, they are on a straight line. So they are supposed to give us 180 degrees, all right? So you could have worked it that way. So if I substitute here, I've got M1, which is x. So M1 is x plus M2, which is 90 degrees. So this is 90 degrees plus angle M3, which is equal to 180 degrees. So from there, I can transpose and find angle M3. So angle M3 was going to be equal to, transpose 90 this side, it becomes a negative. So that's 180 minus 90 degrees, transpose x that side, it becomes also a negative. So that M3 is going to be 90 minus 180 minus 90. 180 minus 90, that is 90 degrees. If you subtract these two, we're going to have 90 degrees minus x. All right, so that is how we could have calculated our M3. So M3 can be equal to 2x, which is okay, or M3 is equal to 90 minus x. I don't know if there's another way that we could have used M3. If you have another way, let me know on the comment section so that we can help with others with your method. But I think these are the two ways that we could have calculated M3. All right, so now on question 6.2, they are now asking you to calculate the numerical value of x. Where are we going to have the numerical value? This is the number, like x is equal to 10 or x is equal to 50 or whatever. That is the numerical value that they are talking about here. So since we have a condition here that we talked about from M3, we can use that as an advantage, because if you check what we said here on M3 from 6.2, we've got two conditions that we saw. From this condition, we saw that M3 is equal to 2x. The same M3 that we are talking about is equal to 90 minus x. So you can take that as an advantage, all right? So on 6.3, we can simply take that as an advantage. So M3 is going to be equal to angle. So if, let's say, you did not calculate this one, you are now forced. So the same explanation that I have explained about this, guys, you're just going to use it. You calculate your other M3. So if you calculated this and you did not calculate this, you are forced to calculate this time, because you need to equate these two. So the 2x that we got here must be equal to the other M3. As you can see, there are two different answers, but representing the same thing, the same angle M3, but written differently. So it means they are the same because they all represent what? M3. So you can create an equation like that to say 2x must be equal to what? Must be equal to 90 minus x. So from there, I can calculate x transpose this x to this side is going to be a positive x. So it's 2x plus x is equal to 90 degrees. This is same as 1x. So 2 plus 1, that is 3x, is equal to 90 degrees. Divide by 3. Divide by 3, you're going to have your x as 3 into 90. That is 30 degrees. All right, so this is going to be the value of x that you that is going to satisfy whatever condition that we are given on this diagram. If x is 30 degrees, it is going to satisfy every condition that we are given on this diagram. So it means that if x is 30, All right, so let us see what's going to happen if x there is 30. Let's just try to interpret something. It means here is 30, here is 30, here is 30. All right, here it's remember we say this is 2x. So it's gonna be this one, it's 2x, which is 30 times 2, which is 60. This is also 60, all right, because these two angles are equal. Remember what we said. So it means that this angle also is going to be 60 degrees. That is what it means, because we are now left with one angle, and angles in a triangle that up to 180. So 180 minus 60 plus 60, which is 120. 180 minus 120, it's 60 degrees. All right. Then here angles in a triangle is going to be 60 60, which is 30 30, sorry, which is 60. Then from 120, from 180, which is 120. So you're going to have 120 plus 30 plus 30, which is 180 to complete a triangle. So this angle P must be equal to angle R here. So the whole of R, but there we have got 60. So 120 minus 60 means we're going to have 60, which is the remaining of R, like that. All right, so that was going to be our triangle. And if you check, it makes sense, because this must give us 180 degrees. This must give us 180 degrees, right? This must give us 180 degrees, all right? The outer angles here must give us 360 degrees. That is 120 plus 60 plus 120 plus 60 must give us 360 degrees. And it actually perfect. This is exactly what it is giving us. So just go through and check if you have got answers like this. It can help you to just revise as a revision sake, just for you guys as you are revising. Okay, this is exactly what I was supposed to do or not. So it's very, very important that you just revise as much questions as you can. Question number 7, you are now given A, B, C, D is a parallelogram. You're back again to another parallelogram, and you're given in this case that these two sides, they are parallel. AD is parallel to BC, as we know that these two, yes, they are parallel, and they are not just parallel, but they are parallel and equal. The same thing with BA and CD. They are not just parallel, but they are parallel and equal. All right, so the question here was using the diagram above, prove the theorem that states that the opposite sides of a parallelogram are equal. And this is what I'm actually saying. And they say, prove that. All right, 5 marks. So how can we prove this theorem that I've been talking about? Say they are not just parallel, they are parallel and equal. Now they want us to prove that they are not just parallel, but they are parallel and equal at the same time. All right. So meaning to say, it's like we do not know this, because they are saying we must prove. So if we put this, it's already something that we know. So you're not supposed to put that. All right, so let us check the way according to way they are bisected. Remember, that's a diagonal there. So let us just put a diagonal here and see what's gonna happen. Remember, guys, this is a proof, and you're supposed to actually know this by head, like all these steps. But I'm just gonna act like I don't know anything, so that you also know. Because if I act like I know what's happening, then you won't be able to know, because I'll be speaking to myself. All right, let's say I do not know what is happening here. I can say, or I can see that these two, they are meeting the diagonals. All right, BD, it's a diagonal. All right, then AC, it's also a diagonal. All right. For the meantime, this does not make sense, because this is just a diagonal. They intersect, they bisect each other. That is what we know. All right. But for the meantime, they does not make sense. All right. Does not make sense. So let me move on another. On the same diagonal that I'm having here, let me just say I'm working with this diagonal alone, as it is. Like I said, guys, I'm just going to act as if I don't know what's happening, so that you understand. So let's say you're thinking this way, to say, okay, from this diagonal that I'm having, I know that this is a sort of a rectangle. Actually, I know that a rectangle is just being pushed like this, and it gives us what? A parallelogram. So there are some properties that we know about this diagonal, like it gives us something common. Say this thing and this thing are the same. Just like what I did on this part, to say this one, if it was like this, all right, it gives us to say that this side and this side are the same. So we can work with that to say this can be given as a common what? As a common side, right? Because it's the same for both triangles, this triangle and this triangle. Guys, I'm acting like I don't even know what is happening. So I'm just gonna say BD is equal to BD because it's common. Because I want to use this triangle, but I don't even know the order. Maybe it's A, B, C, A, B, D, or B, D, D, B, D, C, B, or it's B, C, D, or it is going to be, if we say B, C, D, it is going to be D, A, B. Remember, from the congruent triangles, you are supposed to take in a certain order, which is the same. So that is where I want to go there, because these two, they are the same. And we can see that they are the same, but we need to prove that. All right. So this one is going to be a common. So it's a common side. All right. That's a common side. Just acting like I'm starting. I don't even know what is happening here. All right. We have a common side. Now it gives us two triangles which are equal, but we need to figure them. How equal are they? How are they equal? All right. They are angles which are equal and sides which are equal at the same time. All right, let's start with the angles because the angles can help us a lot. All right, remember we've got parallel lines. And from the parallel lines, we can see that if we are to draw a Z here, all right, like this, I go this side, I go this side like this. I'm having a Z, alternate angles. Angle D1 and angle B2, they will be equal. All right, is that so? So angle D1 is equal to angle B2. All right, so I just don't know what's going to happen with this, but I know that these two angles, they are the same. This angle and this angle are the same. All right, so why are we saying so? These are alternate angles. All right, so these are alternate angles. So we are talking about alternate angles in this case. Which sides that we are talking about? AD being parallel to what? To BC. All right, so that's our AD is parallel to BC. AD is parallel to BC, like that. Okay. Now let's move on to another. Is it the only condition? No. There are some that are the same also. From these lines that are parallel, AB and DC, we are going to see that we've got a continuum again of those parallel lines again giving us equal angles from the Z angles. This time happening at B1 and at B2. All right, so meaning to say, all right, so I want you to be careful. We are using this triangle to this triangle, all right? So because of what we did here, we say D1, which is the, I'm referring to triangle 1. This is my triangle 2. So if I said B1, it means this time I'm going to start with what is on triangle 1. So I'm referring to B1 and what? D2. So be careful on that one. So it's going to be angle B1 on triangle 1. This is on triangle 2. So I'm going to say B1 is equal to what? We said B1 will be equal to D2 on triangle 2. So this will be equal to D2. These are also alternate angles, but for which triangle, which sides are parallel? AB and what? And CD. This is from AB parallel to DC or CD. All right. We have a side which was common, which is the same side because there is just one and the same thing. The sides are the same. We have got angles which are the same. This angle D to the angle B1, angle D1 to angle B2. All right, let's see. If we consider our conditions of congruent figures, because we have got angle, let me present this way. This is the angle that we're talking about. This angle equal to this angle here. All right. So if we consider, we have got angle D1. All right. Take note, angle D1 and angle B1. Here we've got angle B2, angle D2. All right. So meaning to say we have got triangles that are congruent in this case. Congruent in which manner? From D to A to B in that manner. All right. Or from A to B to D in that manner. We are going to see that this will be congruent. All right. Or we can refer as A to B to C in that manner. We're going to say A to B to C, and from D, where I said A, B to C, it is going to be D to C to A. So the way that you are going to refer there is supposed to be important. All right, so we can conclude and see that if I take from D, it is going to be D to A, all right, back to B. In this case, is going to be congruent to, remember I took this way, D, A, B. So it's going to be this other side, all right? I have to move like the same side, the same angle, the same angle in that case, all right? So this is going to be this way, B to C to D, so that I maintain this side, the angle C, and the angle A to the angle D. So this is going to be B, C, D, all right? So it's going to be congruent to triangle B, C, D. These two triangles, they are actually congruent. So if they are congruent, what does it mean? It simply means from D to A, it is equal from B to C. So there we can conclude to say, therefore, D, A is equal to BC, all right? We can also conclude that AB is equal to CD, all right? So you can conclude that AB is equal to CD, all right? Is there anything? Nothing. All right, so that is what we can, and the last one is the common side. Remember, the BD, which is the BD, which is the common side. BD equal to BD. Remember, this is our common side. So that is what you can see. So if you can have this, guys, you can actually obtain full marks, all right? So that's what you're gonna have, and this will be angle side. All right, there, gonna be angle side. So 5 marks for the proof. So for proof, guys, you're going to see, even if you reach grade 12, we're gonna be having these proofs. So I prefer that if you're dealing with the proof, know your proof. It's either you're gonna memorize, or I don't know how best you're gonna do it. But as you are going through revising question papers together, you'll see that you'll be actually understanding this. It will be like a repetition, like you are just doing one and the same thing, because it is the same. They'll ask you the same question in another question, but maybe they're just gonna interchange the letters. So you'll see that it's just one and the same thing. All right, question number 8, let us see what we have. A, B, C, D is a parallelogram in that case, and we're given that these, they intersect, all right, BD and AC. You've got BD and AC, they intersected all here, which is fine. And we're given that AF, A to F, and is equal to OD, is equal to OD. All right, these two, they are equal, all right, as you can see. Then CO and FB, all right, CO here and FB, okay, which is fine. Then BA and BF produced meet at E, all right? There is something produced here to meet at E, which is fine. All right, 8.1, prove that BOAF is a parallelogram. We are back again, proving that it's a parallelogram. So we are just gonna go back to the same concept that we had, but this time let's see how, because it might be different from that one. But we are told that this one is a parallelogram. Remember before, AB, B, C, D, this one is a parallelogram. So meaning to say AD is parallel to BC, and at the same time, they're not just parallel and equal. AB is going to be parallel to DC, not just parallel, but parallel and equal. Remember, we proved that on the question above. So from this part, we can see, I want us to see something here. This time we need to prove BOAF like this. All right. To A, to F, like this. All right, this is the one that we want to prove. Okay. 1, let us consider this. B to O, and this side of BO is the same as OD. All right, this is the same as OD, and it's the same as what we have from this side, because we are given that these two here, they are equal. All right, so we can see that these two sides will be equal. from O to D, remember, it's a parallelogram that we have. So our diagonals, they bisect each other. So it means from B to O, it's half of the diagonal, which is equal to OD. But OD, we are told that AF and OD, they are equal. This one, they are given. AF, remember, we are told that it is equal to OD. This one, we are given. We are already given this. So if it is that manner, it means we are going to say AF and BO, they are equal. All right, so it means AF is going to be equal to BO. AF is going to be equal to BO in that case. This one and this one will be equal. So remember, these are the properties of what? Of a parallelogram, all right? Then another thing that you're gonna need, again, from the same case, AO from AC is bisected again. So AO and OC, they are equal, just like from B to O to C. So A to O, this side, all right? I'm just thought I'm gonna use another one there. So if you check, the same thing that we talked about here is the same from A to O and from O to C. We have bisected the diagonal, because these are the properties of what? Of a parallelogram, that the diagonals, they bisect each other. So this diagonal is being bisected each other. So meaning, say from O to C, it is going to be equal from A to O. So these two sides will be equal, all right? So AO is gonna be equal to OC, all right? Just like that part. So this is the part of the diagonals, all right? So here, diagonals bisect each other. So here, it's all about the diagonals bisecting each other here. Diagonals, all right, bisect each other. All right, so these are the diagonals, or you can just say diagonals of what? Of a parallelogram, all right, of a parallelogram. In that case, bisect, in short, all right? Just write in short. Diagonals of a parallelogram, they do bisect. This is the same condition that we have here. The diagonals, all right, the diagonals of a parallelogram, they do bisect. All right, they do bisect, just like this case. So if they do bisect, it means automatically AO, because before we said FB, before here we are given that this FB here, FB is equal to what? To OC. So if we are given this, automatically it means OC is going to be equal to FB, because AO is equal to OC. So it means FB is going to be equal to AO. So it means AO is equal to FB, all right? AO here and FB, automatically they are equal. So as you can see, opposite sides already, they are equal, all right? Opposite sides are already equal. Opposite sides are already equal, all right? So meaning to say, we can say this is a parallelogram because we are having these opposite sides which are the same. Then for the angles, what you can do for the angles, now we can just maybe use the condition of our angles here. For the angles, we're gonna have, we do not have any other angle that we can use, so you can just use these sides, they are enough, all right? So these sides that we have, they are enough, all right? So with these sides, they're enough. But if we had an angle, you're going to include an angle in that case, all right? So therefore, we can conclude that BOAF is a parallelogram, all right? So BOAF is a parallelogram. All right, is a parallelogram like that. All right, so the condition is we are having these two sides being equal, these two sides being equal also AF. So that means opposite sides of what? Of a quadrilateral equal. And that is what exactly happens on a parallelogram. So you're gonna have that as a reason. As long one of the reasons can be satisfied, it means the shape is a parallelogram, or the shape has been proved, all right? Prove that AD is equal to EA, All right, AD is equal to EA. Maybe we proved that and we did not, but we did not prove anything. All right, remember now this is a parallelogram that we are talking about. So let us prove this and see. This is our last equation to make up the whole paper. All right, so we want to prove that AD is equal to, all right, prove that AD is equal to EA. All right, so we want to prove this. Okay, let's see. Let us see. This is where we have our AD. This is our AD here. And EA, EA, that side here. All right, they are saying must prove that these two sides are the same. A to E and I to D. All right, so equations like this, you can't trace to say, where is it coming from? You have to start the like find time and so, but if you have to consider something here, because here we already know that the whole of this line is parallel to this, isn't it? Because before we are told, that this is a parallelogram, all right? Before we know that this is a parallelogram. So AD, this line AD is found on the same line with the ED. So it means the whole of line ED is also parallel to the whole of this BC, all right? Because before we're saying AD is parallel to BC. This is what I said before. But AD and ED, they are on the same line. Same equation, same line. So it means it is also parallel to BC. And also we talked about the BF, this one, from the parallelogram, because we said these two, they are also parallel. Remember from the properties that we just proved right now, the whole of this BF, which is BE, because BF and AO, they are parallel. So it means the whole of BE is going to be parallel to OA. All right, this one, we talked about this from the properties that, because we proved that this is a parallelogram. Remember, we proved that it's what? It's a parallelogram. So this one is already proved. All right, that is proven. All right, so if these two lines are parallel, then what does it that we are going to get? All right. Remember this here, E and A. All right, let us just note EA. If we take from E to A to C to B, all right, from E to A to C to B, there's something that we are seeing there. All right, what is it that we are seeing? Okay, this side EA, all right, the side of EA in that case, all right, and the side of BC, this one, the side of BC, is going to be the same as what we have on the side of AD. All right, guys, we are just, all right, no problem. There, I'm seeing that I'm actually taking a lot of my time. There we have already proved it, no problem. So from this one, the one that I've talked about, is a long way, because we're gonna see that this side, which is EA, is going to be equal to AD, not because of AD, but because EA is equal to BC. Because BC is equal to AD. All right, so actually we can see that at the end, EACB, all right? Or we can take it as EBCA, like that, is a parallelogram. So there we are talking about a parallelogram. It's gonna be a parallelogram. And if it is a parallelogram, because we've got two pairs of what? Of parallel sides, just like what we had. Remember how we proved, guys, a parallelogram before. So if we prove that a parallelogram, we are using the same thing to prove. So guys, it's just one and the same. So if we proved that the opposite sides of a parallelogram are the same, then it means from E to A, all right? Then it means from E to A, it is going to be equal from B to C, because we said this shape here is a what? Is also a parallelogram, this one. So it means from E to A, it is equal to BC. But being equal to BC, what does it mean? Remember before what we talked about, we said AD and BC, they are the same. Remember that AD is equal to BC. This one is given, all right? So if AD is equal to BC, therefore, we can give it as a conclusion to say AD is equal to what? Is equal to AE, which is EA. Just write the way that I gave you there. AD is equal to EA because we are saying EA is equal to BC, but the same BC is equal to AD. So it means AD will be equal to EA. So proving, I know that from this question, maybe I did not answer you, all of you guys, but maybe a few of you have been answered. I know I understand these types of questions, but what I want you to do is to at least try work with more questions. The more you do these questions, you can easily see that they are repeating the same type of a question, but in another way. So it just needs you guys to revise as much questions as you can, but that is how we're supposed to have, even from the answering of this question, again, that we talked about, you see that it's a repetition, but it's gonna do more questions. I'm going to explain in different ways. By explaining in different ways, then you will see, or you choose a method which is easier for you. But that's what we had from this question paper, guys.